This conference will now be recorded.
Well, since I hope everyone is here and we'll have a lot to cover, we really should begin today's webinar. I really appreciate you all for attending today's virtual conference. A very good morning, afternoon, or evening to one and all present here virtually with me. Let me introduce myself. My name is Rachel McLean, Conference Secretary at Coalesce Research Group LLC. I will be available for any of your queries, questions throughout the webinar to help you out technically and organize the webinar successfully. I would like to thank the attendees or participants of today's webinar and hope you enjoy the webinar and gain the knowledge from the sessions today. We all hope your participation will contribute to new research findings and that will lead to new collaborations and research innovatives. Before we start with the sessions, I guess some of you will be new to the GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or web page, you can find four icons at the bottom center: mic, camera, screen, and or leave. Mic button, click on that to mute or unmute yourself. I request you all to stay muted while other speakers are presenting the research work so that it does not cause any disturbance to them. Camera button, you can use this button to share or unshare the web camera. If you have the option to share the webcam, you can do it, or it's completely your choice. Screen button, you can use this button to share your screen. This is the main part during your presentation. After I call your name from my side, I will be making you the presenter and will give the permission to share the screen, then only you will be able to share your screen. So once I'll make you the presenter, you can click on the screen button and you will be find a pop-up window to share your screen. End or leave button. This is your fourth icon where you can use this to leave the session. On the top center, you can use the options to change your display settings. At the top right corner, you will have the three icons: people, chat, and settings. In that chat option, you can chat with me or any other participants. For the settings, you can use this button to check for the settings of your speakers and microphones. As you have mentioned, kindly remain muted during the presentation so that presenters do not get disturbed. And for any questions, you can ask the questions or you can send us your question in the message box too. Well, let's not take too much of your time. Finally, I would like to request you to please give us your brief introduction about yourself before starting with the session so that we can know about you virtually. And now let's move into our first session by Dr. Lei Zhongqing from the Shuozhou University, China. Doctor, are you ready with your presentation? Dr. Li Chongqing. Let's wait for 2 more minutes to Dr. Li Chong to respond. Dr. Li Chongqing, please respond.
Rachel,
Yes, doctor.
it's me, Kaustubh Kabe.
Okay.
If the professor is not speaking, can I shift my schedule in his place? If
Um,
if he is not speaking right now.
yes, let's wait for a few more minutes, then we can.
Okay. Name is Kaustubh Kabe. Okay.
Okay,
Okay, good.
thank you.
Yeah, you're welcome.
I think he's having some technical issue. Let's move to the next presentation by Dr. Kostu Kabe from Mumbai University, India. Doctor,
All
are you
right.
ready with your presentation?
Yeah, my presentation is there on in the WhatsApp. You have to open it from your side. I'm
Okay,
using a
okay.
phone
Just a few
device.
minutes. Yep.
Good. Did you find it?
Yes, doctor. Just a few minutes. I'll make it.
Okay.
I'll share my screen.
Okay. Yeah, that's it.
Yes. Now I'll share my screen. Please start with your presentation.
Okay. Mm,
So please let
yeah.
me know when can I change the pass. Okay.
Okay. So, ladies and gentlemen, I wish to thank. My name is Kaustubh Kabe, and I wish to thank the organizers and Kathy, Jessica, and Rachel. So, my name is Kaustubh Kabe again. I'm talking about quantum chronoentropics, a gauge model for time and entropy, explaining the relationship between time asymmetry and the entropic thermodynamic arrow. What it means is there is what we call a thermodynamic arrow, and the entropy is always increasing in every spontaneous change. And this is also associated with time asymmetry. And I'm going to try and explain away the dark matter and dark energy effects in terms of a new kind of matter called entropic matter. Next screen. Rachel, next. Okay. This is the problems with the standard model, the standard cosmology. What we have there is a Big Bang, and then there is sudden inflation. Sometimes they say inflation caused the Big Bang. Some people say Big Bang was succeeded by an inflationary era, and then from that slowly matter morphed into different phases. And what we have today is this, the last part on the right, the today's universe with galaxies. And there are, according to standard model, the electroweak unification occurs at 10 to the 5 GeV. At 10 to the 15 GeV, the strong force joins in, but they don't join in exact single point. And this is the essence of the hierarchy problem. And people try to do away with it by explaining something called supersymmetry. Next slide. Okay, the problem of dark matter and dark energy is a serious problem in cosmology. Its existence and inner workings are still a mystery. Recently, people studied Mordechai Milgrom's modified Newtonian dynamics (MOND) theory, and they have claimed a complete explanation for the cosmological data. This one is the WMAP photograph. And okay, however, the predictions of Einstein's general relativity are robust down to all scales up to the Planck scale. So this talk is, okay, next slide. So this talk is about actually building a model that functions below this scale, is sensible and understands the 96% of the universe that is not accounted for by the standard model, and also functions like the dark matter and dark energy of the standard cosmology, as I just stated. You can see this disk here, the pie chart, and you can see that atoms consist of only 4.6% of the content of the universe. The dark matter takes up 24%, and dark energy takes up 71.4%. Actually, it's dark physics, because physics can explain only such a small amount of portion of the universe. So actually, dark energy and dark matter is still not understood, and they call it dark. So actually, the physics itself is dark about it. The supersymmetry predicts something called a weakly interacting massive particles, WIMPs, and massive astrophysical compact halo objects, MACHOs. But nobody knows that they exist. The collaboration is possible only in LHC and future generation of LHCs and accelerators like those. Next screen. Uh, okay. No, next screen. This is nothing. Doesn't concern. Okay, good. Now with the modeling with entropic charge. In the limits of relativity, there is inertia of energy asserted by this famous relation E equals mc squared. Within the limits of the relativistic explorations, we find that for any and every system, there is an internal time clocked by that system, which is related to the strength of the total vorticity of that system. Next slide. Okay, equivocally, the entropic charge has been proposed based on the fact that entropy is Lorentz invariant. Then a D equal to 3 plus 1 Lorentz covariant gauge invariant theory of time and entropy has been constructed in our lecture, and the fundamental asymmetry of time and the thermodynamic arrow due to entropy currents in spontaneous processes have been reconciled into a single manifestation. The gauge symmetry group of the chronoentropic gauge theory is U1, abelian gauge group, unitary gauge group with one parameter, e to the I pi, just a phase. Next slide. Objective. Next slide. The objective. The objective is to examine the association between time, vorticity, and entropy and its consequences. Methods. Now, thermodynamics proposes entropy as a quantity that measures disorder, a degree, next slide, a degree of randomness. However, in light of the theory of relativity, entropy is a Lorentz invariant, and the relation of the passing of time, the expansion of the universe, and the possibility of dark matter and dark energy forces us to think differently. So we bring the property of entropy to the forefront as a fundamental charge, small s, only, in that it is of only one kind, positive. Then the D equal to static gauge theory is proposed to extend the entropic potential as a source of the chronoentropic gauge model. The chronos, by the way, chronos means time, by the way. The gauge field V mu is a Lorentz invariant gauge invariant abelian model U1. The entropic charge as an entropic field and an entropic current. Since the model is an abelian U1, the field, next slide, the field equations are analogous to the Maxwell field equations. However, consider a system with vorticity W equal to del cross V, curl of V, built into it. Then the velocity V is gauge invariant. Then the strength of the vorticity is given by the circulation, gamma equal to integral V dot dl. Now the wave function in quantum mechanics, psi is equal to exponential minus I et. There is the energy, T is the time, canonically conjugate to the energy. And this may be recast as psi equal to exponentiation of minus I m gamma, where gamma is circulation and m is the mass conjugate canonically to gamma. Analytical continuity of the wave function, analytical continuity any function actually of this form demands that Et equal to m gamma, or since E equal to gamma mc squared, next slide, E equal to mc squared, so m gamma equal to Et, there is E by c squared gamma equal to Et, E cancels out and get T equal to gamma by c squared, thus relating time to vorticity. Also, gamma is integral VDL, that is same thing as curl of V dot dA, the enclosing area, and that is same thing as W dot ds, integral W dot ds, where W is the vorticity del cross V. So unlike the conventional Maxwell equations, our equations have a monopole-like character, which is the circulation or time itself. By the way, time in this theory is quantized in terms of Planck's units, Planckian time, 10 to the minus 43 seconds. The entropy and the vorticity field are two different aspects of the same physical quantity, with namely the chronoentropic gauge field V mu equal to into bracket phi s, the entropic potential, comma Vk, the 3 velocity. Where the field equations are given by del mu W mu nu equal to J nu S, entropic current, where, next slide, where W mu nu equal to del mu V nu minus del nu V mu, and J nu S is the entropy vortex current. So we have a gauge field that we link time and vorticity and entropy with. Time, as we know, is a dimension in classical general relativity. However, notice that the Schrödinger spacetime is a gravitational field. Just as excitations of specific quantum fields are the corresponding quantum particles, excitations of space can be entropic particles which interact by means of the gauge fields V mu, which are particles of time. Thus, the scale pertaining to the dynamics of quantum entropics, quantum chronoentropics, is below the Planck scale. What happens when we scale above the Planck length? Next slide, please. Okay, this is a 3D mapping of the dark energy and dark matter. Next slide, please. Okay, spontaneous, no, before that. SSB and the chronons, spontaneous symmetry breaking and the chronons. Okay, now next slide. The local gauge symmetry breaking, this is a cosmic epoch, what I said earlier. These are cosmic epochs. And below Planck scale, time is parachronous or isotropic. Time is isotropic. There is possibility of going in all directions in time below Planck scale. Above Planck scale, what happens, I'll tell you now. The local gauge symmetry breaking takes front seat. This is straightforward standard model like calculation. We give the interpretation directly. Because the Lagrangians are very large, I didn't put them here. They are standard Higgs mechanism stuff. So we give the interpretation. The vector meson V mu, next slide please. The vector meson V mu eats the Goldstone boson via the Higgs mechanism and becomes heavy. Below the Planck scale, that is above the Planck temperature, space is parachronous. The vortices were arbitrarily oriented and they like spins. The rotons or chronons are distributed isotropically. The spins, or next slide please. The spins or vortices change without any force being applied. The fields which carry the vertical interaction are massless. When the temperature lowers to the Planck temperature, space becomes continuous and orthochronous. This is a phase transition. The vortices of the protons turn spontaneously into a common direction. It could be any direction. In our universe, the direction it is the direction of expansion of the universe. The space within the universe ceases to be vertically isotropic, that is parachronous. Instead, it has preferred direction, thermodynamic arrow that I was talking about. The entropic charge assures us of this. As far as the Lorentz rotations are concerned, next slide please. As far as the Lorentz rotations are concerned, the carriers of the chronoentropic interactions V mu now have mass. Since time is the vortex charge, time is not as a dimension but rather as a particle aspect now has mass. Yes, time as a particle can have mass. Thus, time should vary relativistically the same way as mass. That is, m equal to m naught upon root 1 minus v squared by c squared. Similarly, t varies as t naught upon root 1 minus v squared by c squared. That's because time has mass. That is the fully blown post-Learning limit. Uh, this is true and can be seen from relativistic variance of time and velocity and that of mass with velocity. So entropy could be quanta of 3 could be equal to 3 space, and time could be the vestige of the gauge bosons V mu of the vortex interactions between these entropic particles. The question is that can the quanta of the whole of the space be fermionic, since everything seems to work in this model. Also, K Boltzmann, K subscript B is equal to 1.38 into 10 to the minus 23 joule per Kelvin may be taken as a fundamental unit of entropic charge. Next slide, please. Next slide. With SI units of, I'm introducing new units here, SI units in honor of Boltzmann's. Entropy can be said to be 1.38 into 10 to the minus 3 Boltzmann's. The fundamental unit of entropy is K Boltzmann itself. So just like electronic charge, E, 1.6 into 10 to the minus 19 coulombs. Here, the fundamental unit of entropy is K Boltzmann, 1.38 into 10 to the minus 23 Boltzmanns. Now, since there is only one kind of entropic charge, the dominant force in entropic matter is repulsive. This accounts for the dark energy part of the universe. The broken symmetry yields massive chronons, gravitating bosons, together with the entropic matter, the dark matter counterpart of the universe. The repulsive nature of the entropic matter is less as compared to the electrostatic repulsion, as can be seen from the comparison between the magnitude of the electronic charge E equal to 1.6 10 to the minus 19 coulombs and that of the entropic charge mentioned above, that is 1.3 10 to the minus 23 Boltzmanns. Next slide, please. Yet the repulsion is large enough to make the gravitating entropic matter collision free. This accounts for the collision free nature of the dark matter, by the way. Thus, they will not undergo any collisions in spite of the gravitational force acting between them and between the entropic matter and ordinary matter. This makes it hard to calculate the usual particle physical collision or scattering cross sections that are detectable in the conventional colliders. The main plausible observational data is possible currently in cosmological observations and astronomical data. For now, this is just a mathematical or physical model yet to be realized in observations. Next slide, please. So results. We find that there is an entropic static gauge theory, which becomes the reason for the dynamics in the known universe, and from the random motions of particles, atoms, molecules to the expansion of the universe. The entropic matter proposed is a plausible reason for dark energy effects. This is the cosmic void, by the way. Next slide, please. Okay, the U1 gauge symmetry is broken at the Planck scale via the Higgs mechanism, and the gauge field V mu acquires Planck's mass and becomes heavy. So it becomes 10 to the 19 GeV by c squared. That's a prediction of my theory. You will find a particle of time, the chronons, the chronoentropic particle, the chronons, given by the gauge boson, gauge field V mu. These particles have 10 to the 19 GeV by c squared mass. So this corresponds to the polarization of the dynamics in only one direction, like ferromagnetism. Yeah, just like magnets oriented arbitrarily, they become ferromagnetic above a certain temperature. Similarly, the arbitrarily oriented chronons become polarized in one particular direction, and that is the thermodynamic arrow of time. These and the above arguments are the reason for time asymmetry. Next slide, please. Yes. As well as the accelerated expansion of the universe. Conclusion. Okay, next slide. No, next slide. Next slide. Oh yeah, okay, this is the one. No, wait, the previous one. Previous one. It's correct. Previous slide. Ah. The U1 gauge model, conclusion, the U1 gauge model for time and entropy proposed here thereby explains the relationship between the time asymmetry and the entropy thermodynamic arrow. It could also possibly account for the dark matter and the dark energy content of the universe. Next slide, please. Skip that one. Okay. Thank you for lending your patient ears. These are the references, by the way, if you're interested. One more slide. Last. Okay. I'm finished. Any questions? Can you hear me?
Thank you, Dr. Kabir. Is anyone having any questions?
Yes, I have a question, please. Can
Yes,
I
doctor.
ask? Okay,
Okay.
you are hearing me?
Yes,
I
we can
am
hear you. Please continue.
yes. I am Mikhail Ivanov from Central Institute of Aviation Motors from Moscow, and
Okay.
I know very well what means entropy and what nature of entropy. Therefore, I have two questions. The first
Okay.
question, how your entropy just connect with temperature? And second question, invariance of entropy. Usually entropy just no Lorentz invariance, only Galilei invariance.
No, entropy is
Therefore, I
Lorentz
have two
invariant.
questions. Please answer me, please.
Entropy is Lorentz invariant because it's delta Q by T, and Q and T vary with velocity in such a way that entropy delta S comes out to be Lorentz invariant, not Galilean. It's Lorentz invariant. Entropy is only quantity in this thermodynamics phenomenon that's Lorentz invariant. And temperature arises of its own from average kinetic energy of gases. Here, what I've done is I've taken the problem of time, the asymmetry of time, and the content of entropy always increasing in this universe, and the universe is always expanding. I've taken three things together. To tie them up together, I have brought entropy as a charge. It's just a physical model that I tried to construct. The thing is that entropy is a Lorentz invariant, so I took it as charge because even the electronic charge, we don't know what electronic charge is, but we take it as fundamental charge, and it is no Lorentz invariant. Similarly, entropy is also Lorentz invariant, and we take it. I have taken it as a charge, and the other part, the vorticity part, that is a little mysterious one. And the thing is that since E is equal to mc squared, what I found in one of my earlier researches was that T, the time, is equal to gamma by c squared, where gamma is the circulation. So if there is a vorticity, then there is time. And these chronons, or the rotons, or whatever you call them, the quanta of vorticity, they are arbitrarily oriented below Planck scale. And when the temperature decreases above Planck scale, they immediately, like in a ferromagnetism, they align themselves in a particular direction, which is the direction of expansion of the universe. That's the way I saw it. It's intuitive. Then I fudged the mathematics.
Thank you very much for your answer, but I would like to discuss more detail. I hope we can use email and discuss problem of entropy temperature more detail.
Yes, please give me your email ID.
Much.
Yeah, give me your email ID if you want to discuss. I'll send you a blank email.
Thanks.
Okay, thank you.
Thank you, Dr. Mikhail, for your question. Any more questions?
Any other questions? I guess none. Okay. Thank you, Rachel.
Thank you, Doctor, for your presentation and presence. Let's move to our next presentation by Dr. Shamun Islam from China University of Geosciences, China. Doctor, are you ready with your presentation?
Hi, yes, I'm ready.
Okay, now I'm going to make as a presenter now. Please share your screen.
Okay. Can you watch my presentation?
Yes, we can see your full presentation.
The view is much narrow, so let me just move it here. Okay. My topic is evolution of 3D and 4D printing and the laser additive manufacturing. Here are my contents. And so, the additive manufacturing and the 3D printing. The 3D printing possesses the build a three-dimensional object from a computer design, usually by successfully adding material layer by layer, which is why it is also called additive manufacturing. Here you can see that first we build a 3D model and then we slice it up and then put in the printer, and this printer build layer by layer over the layer and in the z-axis and forms a final 3D model. So unlike the conventional machining, casting, and forging processes, where the material is removed from the stock items and poured into the mold and shaped by the means of the dies, presses, and hammers, the 3D printing saves almost 40% of energy and have the following advantages over the traditional process, just like the reduction of the cost, the design, the speed, and the quality, better control over the quality in the case of the properties, just like physical and mechanical. Um, Here are the major 3D printing techniques: the stereolithography, FDM, DIW, SLS, SLM, LMD, and LDW. The last four are the laser additive manufacturing, because these are also the 3D printing techniques, but they are empowered by the laser. So let's see the SLA, selective laser sintering. This is the fast, accurate, and the precise prototyping process. It can produce the objects from the 3D CAD file in just a few hours. They do this by converting the liquid polymers, a special type of the plastic, into the solid 3D objects, and one layer at a time. The plastic is first heated to turn it into the semi-liquid form and then hardens on the contact. The printers construct each of these layers using an ultraviolet laser directed by the X and Y scans uh, just before each print cycle. Rotate, a recorder blade moves across the surface to ensure that each layer of the resin spreads entirely across the objects. Here you can see this. The print cycle continues in this way and made the 3D objects from bottom to top. The fuse deposition molding (FDM). The FDM is a 3D printing process developed by the Scott Graham and is invented by the Stratas Limited. It uses the production-grade thermal plastic materials to print 3D objects. It is popular for just wait. It is popular for producing functional prototypes, concept models, and manufacturing aids. It is a technology that can create accurate designs and process exception stands to the weight. This is the layer-by-layer deposition of the material, uh, ultimately form a 3D object, as you can see from the figure. This is the directing writing. This is also just like the FDM, but in this we use uh, ink instead of the solid materials. Um, directing writing may be applied to greater range of the possibilities materials and thus have a better versatility of the biomedical applications than the lightweight approaches. Compared to FDM, the directing writing can operate in the heat-free environment, as it involves the extrusion of the viscosity ink through the nozzle with the aid of the displacement controlled driving mechanism. The ink is technically in the form of the slurry in the solution, depending on the component's polymer, solvents, and their additives. The ink used in a reducting writing process has to meet the following rheological requirements in order to print with a high fidelity. Number one, exhibit a shear thinning behavior, reduction in the viscosity with the applied shear stress, exhibit uniform flow of the filament like extrusion, and demonstrate the ability to recover more than 80% of the viscosity after deposition. These criteria have been identified for the studies that utilize uh, hydrogel-based inks. Here you can see that this model is building by depositing a layer by layer on the previous model, and hence we can get the finalized model.
Sorry for the
And
interruption, doctor. Please make it as a full screen of your presentation.
okay, just now, can
Yes,
you able to view this?
yes, yes.
Okay. Uh-huh. Okay, the next is SLS technology, and this is the in this 3D printing technology, commonly high-powered CO2 laser, and in some cases ND-YAG laser is used to fuse the particles together. The laser sinters the powder polymers, and usually nylon powder, and in many there's many different kinds of powder, and the metal powders, and even the ceramic and the glasses. This is how it works. That you can see from the figure that this mainly contains the five steps. Primarily, substrate for components fabrication is fixed on the workbench. After that, the protective gas is passed into the forming room to reduce the oxygen content below a required level. Then a thin layer of the loose powder with the usual thickness of 20 to 150 micrometers spread over the structure. Then a thin, Subsequently, the laser beam scans the powder bed surface to form a layer-wise profile according to the CAD data compiled. The last step of the above is usually the repetition of the process. You can see that a layer by layer, a powder is separated over the bed, and the laser scans the model and sintered the material, and then a next powder is separated. The binding mechanism during the SLS mainly can be classified into the four categories: the solid state sintering, triple S, the liquid phase sintering, LPS, and the chemically induced bending and the full melting, which depends on the property of the material input, laser, and the energy density. The SS is the thermal process that occurs at the temperature between the point 0.5 melting temperature and melting temperature. There are the various physical and chemical reactions with the diffusion in triple S process. It involves the neck formation between the adjacent powder particles as shown in figure. You can clearly observe that the free energy reduces with the particle growing, which provides the dominant driving force for sintering the triple S. Triple S can process nearly all kinds of the materials so as they require the necessary kinetic energy is enough to transport the vacancies across the grain boundaries and consolidate the powder via the volume of diffusion. The structural material remains solid throughout, and the binder material is liquefied in most LPS, which is the partial melting process. The LPS contains the two categories such as the different binder mixing with the structural material and the no distinct binder mixing with the structural properties. So far, the mechanism of the multi-component metal powder and the pre-alloyed powder processed by the SLS belongs to the LPS, as shown in figure. You can observe that um, as the first part of the dashed line in the LPS mechanism, since only rearrange the phase take place. The multi-component powder mixture is generally composed of the high melting point and the metallic component acting as the structure of the metal. The low melting and the small amount of the additives such as the fluxing agent or the deoxizes. The apparent liquid phase temperature is carefully determined between these two different melting temperatures by adjusting the laser processing parameters. The binder thus melts completely to form the liquid phase, while the structural melts remain its solid cores in the liquid. The solid particles rearrange under the influence of the capillary force exerts on them by wetting the liquid that results in the densification of the solid liquid system. The SLM as the derivative of the SLS, which belongs to the powder bed forming additive manufacturing. The properties of the some productions cannot be satisfied by the SLS, although the SLS is the common technology to produce the parts for the long term and able to process any type of the material. Thus, the SLM was developed based on the SLS in late 1980s. The major advantage of the SLM are not only the capacity of the repairing parts nearly arbitrary geometry, but also ability to process a variety of the geometries to almost full density, yielding the bulk material properties. The apparatus of the procedure of the SL are similar to the SLM. However, in contrast to SLM, the binding mechanism is full melting, which needs the more energy and sintering and the hot isolation isostatic process. Uh, Here you can see that this is almost all the same, and uh, only in SLM and SLS. The SLM is partially sintering, and the SLM is the full melting of the process. Here you can clearly observe the mechanism from the pictures that how the model builds up. The first layer is deposited on the powder bed, and the layer sinters this model, and the model gradually goes down and along the z-axis, and finally building up the entire 3D component. And after then, this model is removed, and the residual powder can be reused. Almost 70% of the powder is reused. The laser metal deposition (LDM) is a representative synchronous powder feeding forming additive manufacturing method. LDM is also called the laser engineering net shaping. The laser engineering net shaping (LNS), direct metal deposition (DMD), and the laser rapid forming (LRF), and the direct laser fabrication (DLF) in different regions and research institutes. Mm, In LMD process, movement track of the laser spot along with the 3D model sliced into several layers and scan paths. The focus layer beam melts the metal powder fed and creates a molten pole on the substrate. The molten powder solidifies to form a finely object as shown in figure. The next is laser direct ink writing. Laser direct writing. The LDW method is a kind of the indirect LAM technology for the metal, which is different from the direct LAM technology, like SLM and LMD. The LDW apparatus was originally developed by the substitute for the microlithography, whose resolution can reach the sub-micron level and even nano level. The LDW method was used to fabricate the polymer material parts, but it is now widely used for the manufacturing of optical instruments. Nowadays, LDW apparatus has been developed for building the 2D and the 3D structures, as you can see from the figure. Um, in LDW process, a special ink comprising of metallic powder particles and the organic solution is pre-coated on the substrate. A laser beam is focused on the metallic particle film and scans the following and uh, planned path. Finally, the component was sintered and the intact body is removed. So the technology is kind of the intact LAM, and the whole process uh, is like writing on the paper. So the name is laser direct writing. Here are some proposed applications of the 3D printings. It has a wide application in healthcare, agriculture, building engine parts, mechanics, textile, food industry, and many more applications. Here is just for example that Anila Mayberg is a 30-year-old lady from the Melbourne, Australia, who had lost 80% of her jaw due to the cancer. She received world's first 3D printed jaw reconstruction, and a Chinese baby became the first person in the world to have her entire skull reconstructed by the 3D printing, known as the Big Head Baby. The fluid filled 85% of her brain and making her skull 3 to 4 times larger than it should be have, and measuring about 20 centimeter by 20 cm. And here you can easily see. Now, the evolution of the additive manufacturing. As we know that this is also starts from the 2D writing, just like we write or the design on the paper. So there's several 2D designs on the layer by layer forming a 3D object. So from the three-dimensional objects from a computer designs, we moved into the 4D object. And the first picture here you can see that is 3D printing. It's a general 3D design, and when this 3D printed model transforms over the time when exposed to a certain stimuli is the 4D printing. And when it works in the form of the vital organs and shapes some function of life, then it is called 5D printing. And the intelligent object that can decide, response, and perform multitasking operations, then it will be named as 6D printing. And the 70X printing is still unknown. So we are at this step of the 4D printing and in between the 4D and 5D. So the 4D printing refers to the 3D printing of the designs that transform over the time when exposed to the certain stimuli. This is just the mechanism is almost the same. The 3D printer, and we put the smart material, and when we print this model, it has the ability to transform. So important aspects of the 3D printing, the things we need are the simulation software, the simulation software that can present the 3D model, that can make the 3D model and then show its movement. The Autodesk CATIA and open source, and there are several others just like Rhino and even Blender. And multi-materials printer. These are also 3D printers, but they have the capability to print the smart materials, just like Strata, Java, SolidView, and Geometry. And the third thing we need is the smart materials, the materials that change upon the external stimuli, just like shape, memory alloy, and self-healing materials. Here is a general overview, general breakdown of the steps needed in the 4D printing. This figure represents the commonly used 4D printing parts, while the other less popular methods are not included. The use of any of the method is valid for all of the choices. Um, Here is the example of the some 4D printed objects. They're just like the 3D printing objects, but you can observe that they transform over the shape. They transform over the time. Just like here, the MIT 4D printed self-folding surface cube. This is the cube. When heat is given, it turns or bends, and thus when it is printed in the form of a box, the box is closes and transform over time. So we call it a 4D printed object. And the Harvard researchers developed a 4D printed structures, and here are many different types of the structures that transform of materials that transforms over the times are printed by 3D printer or referred as 4D printer. Just like they should be responsive to temperature, uh, electricity, and certain pressure or certain stimuli. This is the MIT engineering project. This is a beautiful polymer flower. When it touches to the material that is hot, then it is immediately bent and transforms the shape and catches it. And there is another type of the 3D 4D printing. That 3D 4D printing is not only confined to the shear memory alloys or the smart materials. We can also, if we print the metals in the form of structures that can move and transform over time, just like NASA 4D printed space armor, then it is also called the 4D printed materials. And there's a comparison between the materials. There are different kinds of materials, and in the last of the presentation, the smart materials are the very good in conductivity, strength, hardness, relatively good, keeping all the properties in constant. List of small materials that we usually use for the 4D printing. They are the small metal alloys properties that their grain size and thermal expansion coefficient as we are discussed, so that we use the different kinds of materials according to their properties. in proposal to the required consideration. Just like we also see the physical properties, mechanical, and the transformation properties, and then we can propose to the required demand. The development of the self-filling polymers, different kinds of polymers, there's a thermoplastic, thermoset, and the thermoset composites that have the various healing approach, chemistry method, and the best healing efficiency and the healing conditions. Just like this material is a copolymer made from the mix of the methyl methacrylate and N-butanoacrylate. The copolymer's molecular arrangement and the conventions are crucial to achieve the self-healing. And there is actually presence of the van der Waals forces that are responsible for the tectonic repulsion between the molecules caused by the temporary dipoles. Heals the polymer by forcing it to components to integrate like fingers on the cleansing hands. Here are the vistas of the 4D printing that we are working in this field to achieve the goal, just like space exploration, construction, architecture, and the medical devices. This is just example of the 4D printing suit. The first in picture you can see that the body of the person is scanned, and then according to the scan, a suit is designed in the computer design CAD software, and then this design is then compressed in the form of to uh, to de-size its net shape, and then printed, and then when open the compressed part, it is open in the form of the suit. This is the 3D printed heart printed by the Israeli scientists that have the human tissues and vessels. It more looks like beautiful, but in the sense of the functions and the function performance, it is not yet developed. But however, it is a good approach. And this is the overview of the materials. Uh, the materials, the type of the material that we require, the design of the printer, and the change of the application. The required consideration. Here are some things required for designing the final model. The thing required is a guide driven by the major application need and aimed as innovative research, and the design, the function requirement and application requirement design promote each other's development in the spiral way. And the material science, technology, and verification and application. Its applications contain the soft robotic variant, UAV, and form engine. Here are some challenges in the 3D print and the 4D printing that shape recovery, just like after a repetition of the several cycles or after a repetition of each cycle, the performance of the material is decreased, and even the efficiency is reducing by every 10%. And so the material denature after the several cycles. So when we use the materials like organic materials and even the polymers, or usually the materials come composite with the metal particles, they denature and performs reactions each time. And the performance changes after each cycle, and the material stability and the efficiency. The efficiency is also required. Constitution. Uh, Here are our goals. When we print the 4D printed materials, 4D printed object, then the goal we must keep in mind, the important aspects are the it should be lightweight, multifunctional, composite, energy loaded, and the photo material structure, and different material structures for the addition as a replacement of the diamond body part. There are a lot of opportunities in this field, and there is still a gap to deal with the other physical properties, such as when we apply the heat, current, pressure, or magnetic field, it gives the response by glowing, color changing, cooling, and making sound, rather than bending or movement. So here are my reference, and thank you so much. If there is any suggestion or any question, then I am available. Thank you. I am done. Hi.
Thank you, Dr. Shamun, for your presentation. Is anyone having any questions?
Is there any question or suggestion?
I think there are no questions. Let's move to our next presentation by Dr. Evgeny Gervikin from Research Medical University, Russia. Doctor, are you ready with your presentation?
Hello?
Yeah,
You hear
Doctor,
me?
we can hear. Yes. Now I'm going to make you as a presenter now. Please share your screen for your presentation.
Just a minute, please.
Yes, now it's visible. Please make it as a full screen.
Thank you very
Yep.
much. Greetings, dear colleagues. Thank you for the opportunity to take part in this webinar. This is a great honor for me. Let me bring to your attention a report on new direct laser lithotripsy technique based on a thermal converter. As is known, currently the endoscopic laser lithotripsy is becoming the most widely used treatment for urolithiasis. Holmium laser lithotripsy allows to break up stones of any chemical composition. This method is based on both vaporization inside the stone, resulting in fragments with uncontrollable size, explosive rupture of a stone. Dispersed fragments may lead to stone recurrence and inflammatory complications. In addition, during the operation, intrapelvic pressure increases, accompanied by pilovenous and pilotubular backflow. If the stones are infected, the spread of the fragments in the renal pelvis can trigger postoperative inflammatory processes and then chronic inflammatory changes in the kidney. According to the literature, the prevalence of stones associated with an infectious agent is up to 30%. Our retrospective study at the urology clinic for the period from 2014 to 2017 showed that the incidence of infectious and inflammatory complications after endoscopics, including percutaneous upper urinary tract surgery in patients with urolithiasis, was 13.4%. At the same time, it was noted that the risk of developing infectious and inflammatory complications is associated with techniques associated with fine fragmentation of stones. Thus, in the group of percutaneous nephrolithotripsy, complications occurred in 34.1% of cases. In the group of contact ureterolithotripsy, 7.8%, while in the group of ureterolithotripsy, this value was only 2.5%. Thus, fine-sized fragmentation technique is a risk factor for the development of postoperative infectious and inflammatory complications. Therefore, the goal was to prevent postoperative infectious and inflammatory complications by optimizing the technique for performing contact lithotripsy, development of a technique for modified litho extraction, controlled fragmentation of urinary stones by the hotspot method that minimizes the release of stone-associated bacteria, biofilms, and their toxins in contrast to traditional methods. Scientists from the Prevolsky Research Medical University and the Institute of Applied Physics of the Russian Academy of Sciences have developed a method based on a laser equipment for surgery and phallotherapy, Lachtamilon, with a light converter. The dyed lasers are certified for medical use with fiber output on the same quartz fiber, though operated in a continuous mode of radiation generation. The laser radiation converter is a layer of graphite powder that absorbs the visible and infrared light. The layer was formed at a fiber tip by applying of a colloidal solution of micro-sized graphite powder in transparent silicone varnish, followed by drying with laser radiation. When the layer is heated to 1000 degrees, the silicon varnish decomposes, forming silicon oxide, which serves as a binder in the coating. This figure presents microphotographs of the T-phase of the fiber with laser radiation converter and of graphite powder particles. The size of graphite powder particles ranges from a few microns to tens of microns. Applying the laser radiation converter leads to absorbing 40 to 50% of the initial laser radiation. In this case, the radiation does not affect the biological tissue itself, but the transforming element that contacts the biological tissue. High temperature is concentrated in the region of the distal end of the fiber. What is the advantage of this method? Modern repetitively pulsed lasers create a shock wave due to the vaporization of water inside the stone that leads to explosive cracking of the stone with the formation of small fragments. The operation of a continuous wave dyed laser is based on the effect of high temperature on the surface of the stone due to a highly absorbing layer applied to the distal end of the fiber. The stone melts with the formation of large fragments. The fragmentation of the stone occurs due to the effect of carbonization when exposed to high temperature. In these pictures, you can see the zone of carbonization on the stone. In order to assess the effectiveness of the hotspot method in liquid, an experimental in vitro study was performed using 78 stones removed during surgery. Medical certified direct lasers were used with different wavelengths: 0.81 micrometers, 0.97 micrometers, and 1.47 micrometers. As a result, the technology was developed for stone fragmentation in vitro by the hotspot method using a continuous dyed laser. In these pictures, you can see that as a result of fragmentation of the stone using the hotspot method, two large fragments of the stone were obtained. In this in vitro experiment by the hotspot method, it was possible to fragment the stones into two large fragments with X-ray density of up to 1000 constant units in liquid for a wavelength of 0.81 micrometers and up to 1400 constant units for wavelengths of 0.97 and 1.47 micrometers. At the same time, a statistically significant correlation was revealed between the time of stone crushing and its X-ray density. The crushing time depended on the size of calculus to a much lesser extent. Please note that as a result of crushing stones by this method, large fragments of stone without small shards are formed. The high temperature at the distal end of the light raises questions about the safety of the hotspot method for clinical use. In order to simulate an intraoperative error, slipping of the distal end of the dyed laser light heat from the stone surface during lithotripsy. A short touch of the activated distal end of the optical fiber to the urethral mucosa was performed, followed by histological assessment of the tissues there. A fragment of the ureter was obtained at autopsy. The morphological assessment of the state of the urethral tissue in the place of direct contact with the fiber, even with a 2-second contact, demonstrates on the superficial focal defect that didn't reach the muscle layer. As a result of the experiments, it was determined that dyed lasers operating in the mode of continuous generation of laser radiation can be safely used to crush stones in the urinary system using the hotspot method. Summarizing the results of experimental studies, it was found that the time of stones crushing by the hotspot method depends on the X-ray density of the stone, and the limitations on the indicator of the X-ray density of stones for dyed lasers with different wavelengths were determined. It was also shown that according to the data of thermometric and morphological research methods, the hotspot method can be safely applied in the clinic. In order to study the porosity of stones, which which is dependent on the X-ray density, we weighted 8 stones extracted during the operation. The X-ray density ranged from 460 to 750 pounds per kilo. Weighted immediately after removing the stone, then crushed until 2 fragments were obtained. The weight after crushing ranged from 91.6 to 93.4% of the original weight. After drying for a week on the open air, the weight of the fragments of each stone decreased from 78.2% to 83.3% of the original weight. This proves that porous stones contain an organic component, including microbes, which allows them to be fragmented by the hotspot method through the effect of carbonization. The algorithm was developed to perform the operation of controlled stone fragmentation by the hotspot method using a continuous direct laser, and the indication for lithotripsy by the hotspot method were determined. Patients with suspected infected urethritis and patients with stones with an X-ray density of up to 1400 unfolders. For the first time, the hotspot method was tested in the clinic as part of a clinical study. Permission was obtained from the local ethics committee of the Privolsky Research Medical University of the Ministry of Health of the Russian Federation to conduct a clinical study of the possibilities of applying the hotspot continuous wave direct laser technique to stone fragmentation and urinary system. 10 lithotripsy operations were performed in the bladder cavity. At the same time, in all cases, the technical result of the controlled large fragments crushing technique was achieved, obtaining 2 fragments of stones. Also, 5 lithotripsy operations were performed in the pelvic cavity of the kidney. This video, please. Sorry. I have some problems with video. Can I show the video here? Sorry, I have problem with video, but unfortunately, I have some problem with video. But this video demonstrated the process of crushing of stone using a direct laser by the hotspot method in the pelvic cavity of kidney. There is the formation of several channels inside the stone, resulting in fragmentation of the stone. And after the finish of formation of 2 large fragments, they were subsequently subjected to extraction from the pelvic cavity. In conclusion, let me summarize the following results of the research. A retrospective analysis of clinical data showed that infectious and inflammatory complications are frequent in patients with urethritis after operations associated with crushing stones, as well as in patients with infected urethritis, which may be due to the release of bacteria, biofilms, and their toxins associated with the stone. The hotspot technique based on direct lasers with a wavelength of 1.47 micrometers can be successfully used to fragment potentially infected stones with an X-ray density of up to 1400 Hounsfield units. In order to minimize the risk of post-operative infectious and inflammatory the algorithm for performing the operation of controlled fragmentation of jewelry stones by the hotspot method using a continuous direct laser has been developed. Let me express my gratitude to the members of our team, Olga Stresova, Nikita Biturin, Vladimir Kritikhin, Vadim Lagin, Vasily Vlasov, and Vladislav Kamensky. Thank you very much for your attention.
Thank you, Dr. Irving. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Li Chongqing from Suzhou University, China. I'll be sharing my screen for his presentation. He'll be presenting from his side. Let's move on to the next presentation by Dr. Harry H. White. Thank you, Dr. Lian Chang. Is anyone having any questions? You can question that in the chat box so that he'll be responding to your question.
Just I have a small question. First of all, thank you very much for very interesting presentation. But for me, very interesting also. Now we know superluminal motion in cosmic jets. Superluminal motion. Have you possibility to simulate superluminal motion of matter using your methodology? Thank you.
Thank you. Dr. Lian Chang, please respond to the question in the chat box.
Yes, it's question. What simulate superluminal motion of matter, real matter, baryonic matter?
I think he cannot listen that much properly. Please question that in the chat box so that he'll respond. Dr. Mikhil, please place your question in the chat box so that he'll be responding to your question.
Okay. No, enough. Thank you very much. Okay.
Yep. Thank you, Doctor. Any more questions? I think there are no more questions. Let's move to our next presentation by Dr. Cahalio from Digabri University, from University USTO MBA Oran, Algeria. Doctor, are you ready with your presentation? Dr. Kahulyo. Please respond, Dr. Kaula Jafri. Doctor, please unmute yourself so that we can hear your voice.
Yes,
Can you hear me, Doctor?
you can hear me now. You can hear me?
Okay, now I'm going to make you as a presenter now. Please share your screen.
Yes, I
Yes.
will.
Yeah, I made you as a presenter now. Please share your screen.
But I don't have anything to share. To share your
Okay.
screen or something.
You need to click on that screen button so that you will be able to present your PPT.
Yes, I can. It's not in. There is no problem if connected. There
Hello.
is a problem. Hello.
Hello. Can you hear me, Doctor? I
Can
made you
you
as a
hear
presenter.
me?
Yes, I can hear
Yes,
you.
I can hear you.
Yeah, I made you as a presenter now. Please unclick
That's
on that
good, but
screen.
I can't share. I can't share the screen.
In the bottom of your GoToMeetings app, you'll be having third icon
Option.
screen sharing option. You need to unclick that so that you'll be able to
Right.
share your screen.
I go to the option. It's not changing the screen. Switch to different font. Wait a minute. It's not able to share it. Why?
Or else please rejoin in the webinar so that you'll be able to open that. I think you can able to share your screen then. Please rejoin in the link again so that you'll be able to share your screen button. Doctor, are you able to share your screen now? Dr. Dijabri, can you hear me? Let's wait for a few more minutes to respond. I think she's having some technical issue. Let's move to our next presentation in the meanwhile by Dr. Marco Kosicki from Vinca Institute of Nuclear Sciences from Siberia.
Hello, can you hear me?
Yes, doctor, we can hear you.
Excellent. May I
Yes,
share my
now
screen?
yes, now I'm going to make you as a presenter now. Please share your screen.
Okay, let me introduce myself. My name is Marko Ćosić, and I come from, or more precisely, I work in the Vinča Institute of Nuclear Sciences, Belgrade, Serbia. And this is one of the largest institutes in the country and probably the best known one. And inside of it, we have laboratory of physics. And inside of laboratory of physics, there is a group which studies complex and catastrophic phenomena in physics and biology. So we are not only confined to the nuclear matter only. We try to look on different systems and of course related to the nuclear science, to quantum mechanics, but we try to look at from the non-linear perspective, non-linear dynamics perspective. And now I will present to you our latest results regarding the analysis of Bohmian dynamics in positron transmission through a Hero nanotubes. So Marko Ćosić is the first guy listed here, and these are the names of my collaborators which were involved in this particular research. So after this brief introduction, let us begin. So what are the nanotubes? Well, for our purposes, it is sufficient to think of a nanotube as a sheet of graphene rolled up to form a tube. And we can think of a nanotube as formed by atomic strings, which are placed at some regular intervals around the circumference of the nanotube. Well, since we are working in a nuclear institute, we were interested to learn, is it possible to use nanotubes for guiding of particles, or in this particular case, ion beams? Since nanotubes in principle could be manufactured and they can be very long. So there are some proposals to use nanotubes for interconnections inside the chips of future generations, or since nanotubes can be made very long, even for some other exotic applications like sources of electrons for next generation screens, etc. So we were motivated to investigate specific kind of motion of particles inside of nanotubes, which is called channeling. And this mode is characterized by existence of very well-defined trajectories. So it is not similar to the motion inside of solid of arbitrary orientation, where particle trajectories are mostly random. And experiences a set of random collisions in channeling. You need to have ion beam which is almost parallel, very parallel, and directed along the symmetry axis of your material, in this particular case, an axis of a nanotube. And if your divergence of ion beam is sufficiently small, then interaction potential of your particle, positron in this case, and nanotube will be able to capture and contain your particle inside in transverse plane, and it will gently guide, steer its motion. And since nanotube can be made very long, gentle bend of the nanotube can then guide your ion beam very effectively without the need for any external magnetic field. So this is our motivation, and because of it, we wanted to investigate dynamics of this kind of motion. But this analysis is by no means confined or applicable only to the motion of atoms inside the nanotubes or confined to this particular channeling motion. Our analysis applies equally well to any particle moving inside the potential well. So we choose to analyze chiral nanotube 11.9. And what that means? Well, to reduce it to the layman language, this nanotube is formed by a very large number of atomic strings. That means that the resulting interaction potential is practically azimutally symmetric. So to construct interaction potential, we take ion or proton-carbon interaction potential, which in this energy range can be modeled by Thomas Fermi interaction potential, which should be averaged in longitudinal direction. We can do this because transmission energy, positron energy is large to compare to the energy interaction potential of positron nanotube. And since there is a very large number of atomic strings, we can average it additionally in azimuthal direction. So we end up with expression here, which depends only on the radial coordinate. So this particular functional form is not important, but what should be understood is that it forms a potential well for radial coordinate less than radius of the nanotube, and it has decreasing potential for positrons outside the nanotube. And this part will be significant when we analyze quantum motion, because wave function cannot be contained only in this region inside of the nanotube, but it can tunnel outside of it. And to have more realistic model, we also introduce thermal vibrations of atom by averaging the interaction potential by distribution of thermally induced displacement, which are taken to be given by this Gaussian law. And this actually represents the interaction potential in the so-called mean field approximation, which is almost always used in condensed matter physics. You do the same trick when you introduce thermal vibrations into your model of diffraction, electron diffraction, neutron diffraction, etc. So let's start first with the analysis of classical motion of positron trajectories inside the nanotubes. And we write down the Newton equations and we solve them, and we have a very efficient solver for do it. It's no secret. It is Runge-Kutta method of higher order, in this particular case 8.3, if anybody is really interested in these numerical details. And we can now see evolution of family of positron trajectories, which are captured by the interaction potential of nanotube and confined to move in this channeling motion. And since our interaction potential is azimutally symmetric, we can simplify our analysis considerably and analyze only one particular cross-section. And effectively, we are analyzing a one-dimensional system. And this is also will prove to be significant because from nonlinear perspective, this dynamical system is regular. So there are no computation from nonlinear dynamical standpoint. This system is not so interesting. It is considered more or less trivial or well understood. But what is really interesting, and in my opinion, not emphasized enough, that in any kind of motion, usually your period of your trajectory will depend on input parameter, and this will lead to formation of these lines which capture your eye immediately, which are shown by colorful lines, for instance, which are called in mathematical term envelopes of this family function. We have one here for two branches. We will join together at the axis of the nanotube and disappear afterwards, and we have repetition of the same pattern afterwards. In optics, those lines are known as caustic lines. And what is really interesting, if you observe this graph, you will notice that they separate an area of different multiplicity of mapping of starting position to the correct position. So what I mean by that? Well, if we take this point here, we have 0 trajectories crossing any point in this region, while in this region, just below the caustic line, we have exactly 2 trajectories which are crossing to any point in this region. And same applies here. In this region, we have 2 trajectories, while above here we have 4. So this is a general feature how multiplicity changes when it encounters the caustic line. So multiplicity must change by 2, and this is actually subject of catastrophe theory and singularity theory, and these theories, which are based on topology, put very strict limitations on evolution of these particular shapes, and they actually are providing us with a very nice way how to model this kind of shapes, and we can deduce reduced potential, which in gradient for gradient dynamical systems can give these curves immediately. This is from mathematical standpoint, but from physical standpoint, density of the trajectory is very large. Near trajectories, it is mathematically infinite. So our spatial distribution, if we take one cross-section, for instance, here, will have large peaks on the positions corresponding to caustics. So we will have very low intensity, spatial intensity here, and we will have a large peak when we encounter this scattering position, and then we will have decreasing yield, which then will start to increase, and we will have additional very large peak when we encounter the second caustic length, and so on. So this arrangement of caustic line actually determines the shape of our also quantum distribution when we analyze the transmission of quantum particles. And what we expect is to see large yield or large probability density near this classical caustic line. And why is this system regular, and how can we see it if we inspect caustic lines? Well, we can immediately notice that we have very regular evolution of this caustic line. They all appear, actually this particular point, focus point, repeats itself very regularly. All caustic lines have exactly the same shape. I just showed the sample of this behavior. You cannot see them because there are a large number of them, and they gradually became elongated, and their number steadily increases with time. So we are now, this is actually related to the regularity of this classical system. Now let's see what happens when we try to analyze motion of quantum particle in this potential. and we write down the Schrödinger equation, and we assume that our initial state is Gaussian. For technical reason, it is taken to have a large standard deviation because our solver doesn't like jumps which would be introduced if you analyze motion of plane wave inside of this system, because we can only simulate finite computational supercell, and we have efficient solver to solve this equation. It is based on Kostlov Trebuchet global propagator, and resulting spatial distribution of probability density of positron finding its side. I should say that the initial impact parameter of this large Gaussian wave was 0 for simplicity. We see this very complicated shape, and density was color-coded according to this shown color map. So 0 of probability density correspond to this very dark blue, and maximal value is given by the maximal number of red. So your eye can immediately recognize the shape of patterns, wave pattern associated with this acoustic line. All of you who have more experience with diffraction, you can probably recognize this is a canonical cusp diffraction pattern. And because of large number of caustics afterwards, this diffraction pattern then become very complicated, and for longer nanotubes, it is very difficult to recognize this particular classical caustics. But what is striking here, what is actually not so very known and not so obvious to expect, that zeros of wave function, which represents places where phase function is not defined, and it is known under various names like phase singularity, vortex, or using original terminology introduced by Michael Berry, dislocation. We see that dislocations appear, and they have regular structure, and they're more, and even more, they form dislocation change. So one example here is shown by these green lines. We have chain dislocations which are aligned and form this dislocation chain. And another example would be this neighboring cusp line, and we can see here a large line, dislocation chain line, and one also here. And what we can observe that the distribution of this dislocation is rather complicated, and we can see that their number steadily grows inside, and we will not bother ourselves with low values of wave function outside of the nanotube, because this is just part of the initial wave function, which is not captured by the potential neutron. We will disregard it for the further analysis. And we ask ourselves, is there more to it, to this dynamics of these dislocations, or can we say more about it? So we wanted to analyze something which is maybe easier to do. We tried to analyze it from the nonlinear dynamics perspective, and in that regard, we introduced quantum trajectories. So quantum trajectories or Born trajectories are very well known in physics, but usually they are analyzed when people are considering possible different interpretations of quantum mechanics, and it is usually not so easy to calculate them. So practical calculations are very scarce, but again, I should point out that we have alternative method to calculate wave function, and we can actually use phase of the wave function to extract Bohm trajectories without the need to solve equation which define them. But let's just briefly remind you what quantum trajectories are. Well, they are just another use of so-called method of characteristics, which can be used to solve arbitrary hyperbolic partial differential equation. And in essence, this method reduces to finding appropriate nonlinear coordinate transformation along in which your partial differential equation, Schrödinger equation in our case, will decompose into the system of differential equations. So how does it work in this particular settings? So we start with the polar decomposition of wave function. We plug it in into Schrödinger equation, and we separated imaginary real part of our Schrödinger equation, and we end up in we obtain continuity equation known from classical fluid mechanics and so-called classical-like Hamilton-Jacobi equation, which has additional term Q, which is actually represent quantum corrections to this, in any case, classical inform or totally equivalent classical Hamilton-Jacobian equation. So how do you perceive and define trajectories? Well, you know that S function, phase function, is represent the wavefront, and definition of the wavefront is that its gradient represents it's connected with the velocity field in which fluid elements move. So we then introduce artificial coordinate of this fluid element, which Bohm declared to be position of real particle, but let's not go with this philosophical debate. And we end up in this system of first order of equation, which then is related to this classical dynamics of these Bohmian positions, which define the Bohm trajectories, which are moved in potential given with this classical term, which represents classical interaction potential energy of Bohm particle with correction coming from this quantum potential. So let's see why we do this. Well, because we have reduced our complex wave function to the set of real family of Bohm trajectories, which are plane curves, and they actually represent a solution of some, let's not go into philosophical details, but in some abstract dynamical system. And what we can do now, we can apply very well established framework and theoretical tools developed in classical nonlinear dynamics to analyze such a family of functions. So let's see how it works. Well, we first investigated the quantum potential, and what we learned immediately, and it is rather easy to show, that at this location, quantum potential is infinite, negative infinite. This also introduced negative slope because it's otherwise it must be continuous. So in principle, we can immediately conclude that when your Bohm trajectories comes very near to the dislocation, so place where wave function, classical wave has zero amplitude, quantum force acting upon it becomes infinite. So this immediately suggests that they will have profound consequence on dynamics of such trajectories. And we here can see this very blue line. Of course, it's impossible to accurately represent minus infinity, but you can see that this very dark blue line, and please believe me that we checked it explicitly, this is the lowest value we obtain in our calculations. And here, this green line represents the same dislocation chain you observe in previous graph. So let's inspect and compare classical analysis and classical behavior, classical trajectories with the behavior of bomb trajectories. So for simplicity, I have calculated and show here only a subset of classical trajectories near the first caustic line, which is given by this magenta line. And what we notice immediately, classical trajectories can cross itself because the evolution is intrinsically given by differential equation of second order. If equivalent system, Hamiltonian system, first order has two dimensions, so a classical trajectory cannot cross into the fast space, but in real space they can cross, and this is the reason why we can have a caustic line in the first place. But this is something which is totally forbidden for the quantum trajectories, which are shown in this graph here. And we can immediately see that they are actually streamlines. That will be more probably appropriate name for this kind of trajectories. Trajectories are a confusing term, and we can immediately see where our trajectory encounter dislocation. They will split and they will be separated into the two subgroups. One is going up and down to the below the dislocation, and we can see what is expected, that trajectories are very dense in the region close to the classical line. And since we have local repulsion of trajectories, natural thing to investigate it, what happens with the local Lyapunov exponent, and this is its formal definition of finite, something which is called finite time Lyapunov exponent, but in essence it will tell you if it is possible, it is positive. It tells you that neighboring trajectories are repelling each other in this particular time instance, and if it is negative, they are attracted to it. So we calculated this local finite time local Lyapunov exponent for each boom trajectory, and obtained map is shown here. So let's neglect this part here because it corresponds to the part of the wave function which will tunnel outside of this potential, and motion in the free space is not considered complex, so we'll disregard it for our analysis. But we can clearly see that red part, which corresponds to the positive Lyapunov correspondent, happen almost immediately. Occurs actually at the places where are located dislocation line, and this is caused, and we can now conclude that this is actually caused by the action of this infinite quantum force, which will remain infinite regardless how small your wave amplitude in the neighboring area is. And we know that positive Lyapunov exponent is very significant because it is related to the measures of complexity or chaotic, or for characterization of chaotic dynamics. So we analyze this positive local Lyapunov exponents much more carefully, and here is the whole spectrum of Lyapunov exponent calculated for all considered bomb trajectories. And what we can see, we have initial very large positive Lyapunov exponents, but analysis, it's very easy to show that this is connected with the first part of evolution where our wave is actually coupling with the nanotube, and this peak actually corresponds to the splitting convolutional wave function, and it's given by the expanding wave, which is actually not coupled to the nanotube at all. So we will neglect this initial very large spike, we'll not analyze it at all, but we will focus, for instance, in this later area where we can conclude that all transient effects are finished, and we are entering in the steady state motion. What we can see, in contrast to the classical system, which has zero Lyapunov exponent, which is actually a requirement of and consequence of its regularity, baseline curve, or in technical term, negative, limis infimum is negative, but its upper bound, which is technical term called limis supremum, which will be given by this approximately curve here, is positive, and we claim that it will be positive because it is connected to the encountering of bomb trajectory with dislocation, which will shoot it up because in this region infinite quantum force acts. So what it means that this system, which is classically regular, is not regular when we investigated dynamics of corresponding Bohmian trajectories. Why? Because limis infimum is negative and supremum is positive, and regular system are defined to be one for which these two values coincide. We should be very careful in analysis of this result, because at the first glance it seems that suggests that our system is chaotic. We have positive limis supremum, but this is not true, because necessary requirement for manifestation of classical chaos or chaos of Bohmian trajectory is that our manifold formed by current position of bomb trajectory must fold on itself. So two essential ingredients for manifestation of chaos are folding and stretching of this manifold and existence of positive so-called global Lyapunov exponent, which is actually given by z equal to infinity limit of limis supremum of all this curve, which is known as global Lyapunov coexistence. But chaos is out of the question for this particular curve, but this dynamical system is complex. In which sense? Let me return back here. If you observe your bomb trajectories with any finite precision, you actually are following some class of these trajectories, and when they encounter and you are witnessing with finite precision, and when they encounter dislocation, this family can be split in two, and one part of it can go up and other can down, and this lower part can encounter second dislocation, which can be split again, and then resulting subsystems, sub-ensembles could be separated by more than your resolution, and there, in that regard, observation of your system can give you more information about initial positions of your Bohmian trajectory, which are better than resolution of your detector. And the same logic applies when you are observing chaotic systems. So in principle, because initial exponential sensitivity of initial condition, which is basic ingredient in explanation of manifestation of classical chaos, your subfamily of trajectories will split in time, and then even if you have finite resolution, they can be split by more than your resolution. You will be able to then recognize them and to reverse dynamics in time and to get specification of initial condition better than resolution of your detector. So in that sense, both of these dynamics are generating the information, and this is actually a recurring theme in definition of complex systems. So regular system can be observed in arbitrary time, but your observation will give you another fact, but this fact will not produce a new knowledge. On the contrary, when you are investigator or observing the complex system, be it chaotic or not, your new observation will again produce a new fact, but this new fact will reveal new knowledge. And this is I would like to put in a simple, try to formulate in a simple term and to explain in a simple term why this system should be considered as complex. This is the main point, main conclusion, which we derived from our analysis. So dynamical bond trajectory is not regular, it is not chaotic, but it can be considered as complex. It is a very interesting example where we have that classical system is totally regular, but quantum system is complex. Thank you very much for your attention.
Thank you, Dr. Marco. Is anyone having any questions? I think there are no questions. Thank you once again for your presence and presentation by Dr. Marco. Let's move to our next presentation by Dr. Zebri from the University USTOMB Oran, Algeria.
Yeah.
Okay, now I'm making, yes.
Yes.
Please
Thank
let
you.
me know when can I pass the file.
You can hear me?
Yes, we can hear you. Please continue with your
That's
talk.
good. Yes, I will start. Hello, everyone. It's my pleasure to be here and present my work. It's about study of magnetic and electronic properties of UEMB03 perovskite using DFT plus U, and should be talking about the next one. We can start with a little definition about the perovskite. The magnetic elements based on the perovskite have been the subject of several recent experimental and theoretical studies. Recently, previous studies have shown that at room temperature, EMB03 adopts an orthorhombic structure of EMA space group with a ferromagnetic behavior. The object of our study is to relay the idea. It's to provide a new insight into some electronic and magnetic behavior of EMB03 orthorhombic structure. The figure below, it shows the space group of EMA orthorhombic with the parameter A0, B0, and C0 initial. That's what found in our result. The next one, we talk about this result. We can find this result by using the code VN2K. That code is about, it is It is platform of Unix using Photon program linked by shell script web to web. We are using this program to calculate many properties.
Dr. Jebri, are you there? We are unable to hear your voice. Dr. Jebri, are you there? We are unable to hear your presentation. I think she's having some network issue. Let's wait for 2 more minutes. Dr. Jibri, can you hear me?
Now you can hear me?
Yes, now we can.
Hello?
Yes, now we can hear you.
Yes, I found that we are used to calculate our properties using a code vien de K. That's code. It's a platform of Unix or Ubuntu using Fortran program linked by shell script web to web. This program can be properties, structural, optical, or magnetic. This program is concept. This program is inflated or based on the DFT functional. The DFT functional based on Kohn-Charm equation, like shown in the figure below. The next page. Yes, this is the DFT concept. It's based in Kohn-Charm equation and solution. You can use it in full potential. This full potential We have method is BBU GGA and BBU sol GGA. We have a correction with GGA is U bar, le terme U bar, and modification BG and BG. That's what we use in our result. We see now the mechanical result. The table below, it shows the mechanical result. The table below shows the mechanical of our
Dr.
excuse
Jyoti, I
me.
think you're having some network issue. We
Yes,
can't
yes,
hear your presentation properly.
you can hear me now.
Now I can hear you.
Yes, excuse me for that. Yes, please can you give the next, yes, full result. We can now go to the mechanical properties. The table below show the calculate elastic constant. Those elastic constants have a positive value. This value, it means our material is stable mechanical. The next related value, we can calculate the Young module, bulk module, and the share module. Using a different method, Hill and Rush and Voy. 3D dimension of Young module. From this figure, we can conclude our material are stable mechanical and anisotropic. Anisotropic. Please can go to the next figure to show with the others. Excuse me for that. This problem is connected. Yes, this is the figure I talked about. It's the Young module in 3 dimensions, in 3 axes, X and Y and Z. This figure presents anisotropic characteristics of our material. The next one below, it shows the moment magnetic total and partial of PeMbO3. The moment magnetic of is large. That means material have strong, and we also calculate Curie temperature from using the code SPR-KKR. What means also we have improved our material is ferromagnetic material. We have used a different approximation, GGA plus U, and TB MBG, and RADI-AG MBG. That's what you have from the magnetic properties. The next one, electronic. The figure below shows the spin up and down of electronic band structure and total density. GGA plus U, or plus term here about U, show a metallic behavior. And the next one is the MBG calculation. By the TB MBG, it's showing little can be see different characteristics. Our material is a metal, but when we use the approximation GG MBG, we have shown a semiconductor and a half metallic. That's a different characterization is being to the transition material, niobium and mixed with the oxide or opinium. The next page, yes, this is the right is show semiconductor with a gap 0.75. When used the other method of correction MBG, TB MBG, show it's a half metallic. The next page. Yes. Finally, conclusion. Yes, the conclusion. By analyzing the obtained result, the conclusion is listed by properties. Structural obtained results are in agreement with those found previously. The value of the elastic constant have confirmed the mechanical stability. The value of the elastic have confirmed the magnetic stability of UU-MbO3 in orthorhombic structure, magnetic and electronic properties have been investigated, taken into consideration correction Hubbard and MBG. The obtained electronic result with GGA plus U are similar to those found in previous, but those obtained by MBG have shown very different behavior. The value of the magnetic moment the difference between the form electronic behavior and the temperature and Curie temperature have been estimated and shown that this compound retain its structure. And thank you, and I apologize for this taken along and mistake. If I have any question?
Thank you, Dr. Jabri. Is anyone having any questions?
The screen or camera are being shared.
I think there are no questions. Thank you once again for your presence and presentation by Dr. Jabri. Let's move to our next presentation by Dr. Ivanov Mikhail from Central University of Aviation Motors, Russia. Doctor, are you ready with your presentation?
Yes, thank you
Okay,
very
now
much.
I'm making you as your presenter now.
Now I
Please
would
share your
like
screen.
to show my presentation.
Yes, I
And,
made you as a presenter now. Please share your screen.
yes, with one. Okay, and you can see just moment. I just present Central Institute of Aviation Motors, and in Moscow, just my presentation named Conservation Law in the Modern
Sorry
String
for the
Theory.
interruption, Dr. Michael. We didn't see your presentation.
Yes,
Please share your screen.
just a moment. Now we can see, okay, with one, yes? That's all. Have you seen
No,
my
doctor.
presentation?
No.
No,
No,
just
you need to click on that screen sharing button
just
in the
moment once
bottom.
more.
Yeah.
I would like to share my screen. Just
You need to click that screen sharing button.
yes, just one moment. Then once more, yes, and okay. Just yes, and I
Yes,
show
now we
my
can see your screen.
yes, we
Yes.
can see. Okay, for here my presentation
Yes.
and with that's okay at
Yeah, it's
present
now
time.
perfect. You can. Yep.
Have you seen my presentation?
Yes, we
Screen.
can see your
Good?
presentation full screen.
Yes, that's good. Therefore, I can begin. Yes. Thank you very much for possibility to present my paper here. And I present Central Institute of Aviation Motors, Moscow, Russia, and names my presentation Conservation Law in the Modern String Theory for Force Fields and Nuclear Matter. First of all, I would like to emphasize that classical gravity is the residual Coulomb interaction of baryonic matter concentrate in nodes outside of the screen radio Debye-Gökel, was the potential phi is described by quasi-linear Poisson equation present here. With the main idea of my presentation. But in this talk, I present experimental of 21st century, trouble with physics 20th century. Next, classical gravitation without any paradox, dimensional analysis with temperature and medium density of universe, after string theory, conservation law, and with relation, steady relation, Poisson equation, and conclusion. First of all, I would like to, we have no paradox for this case by Bentley, the Allegro delta function, because if we using for potential, force potential Poisson equation, we have no any paradox. And here present at the bottom two-dimensional and another three-dimensional calculation results for this equation. Also, in this talk, the fundamental laws Newton and Coulomb are sequences single law that potential of force field phi present here without any paradox. And green function of this relation demonstrate deep unity, different branch on steady physics problem and Newtonian gravitation field theory. But we have troubles in physics at present time. For example, big trouble with elementary physics, though of particle in Large Hadron Collider during the last 10 years, we have 55 new carbon of Large Hadron Colliders. We can see here I cited published results from this paper. After the main question, detection of superluminal motion of the jets, radial jets of different galactics and quasars. Now, for example, in this paper, we have 6 times more than light speed, and no, for example, 3 times more. In very important results because we just at present time we cannot use no different theory of relativistic theory. Also, for example, I show you at present time with cosmic jets from galactic M87 jets, and we can see how measurement of with the speed of light. Therefore, active quasar and galactics show us with 2 jets which spread off after. And we realize Brighton cycle from each active galactics and quasars. Also, extreme supernal motion of jets from these galactics. In this case, we have 37 more times than speed of light, and 22 or 10 times more than speed of light. And this published with author, and we in future should be taken account such type of velocity of jets and possibility to have for matter velocity more than speed light. Therefore, speed light no maximum velocity in our universe, for example. Also, here present jets, cosmic jets, and we have many examples published at present time, which show us that general theory of relativity in this case don't work, don't true at this time. Also, superluminal impulse will registered in the last century, 1967, from academician Basov, and we can see 6 or 9 times more than speed of light. And therefore, another difficulties, another paradox, pressure distribution inside the photon. Up to pressure registered up to 1035 pascals, very big pressure. And when proton has velocity equal 0, typical presentation with proton and neutron. But if velocity near light speed, we have shear quark in proton, and in this case, structure of proton just change. For example, another picture show structure of proton, shear, gluon, quark, and so on. Therefore, at present time, we have just very big problem for standard theory, physical theory, standard theory, for example. Therefore, we consider Newton gravitation without paradox. I would like to emphasize typical paradox Bentley, Zeiliger, and delta function. According to Newton, each star in a universe ought to be attached toward every other star, which Richard Bentley paradox shows us that the stars should be remain motion at a constant distance from each other, but should all fall together to some central point with Bentley paradox. But if we use such type of motion 4 star with paradox just absent. The Liger gravitation paradox in the unified universe show that this equation there is finite solution. And more another paradox. But if we consider such type of gravitation force field potential, we have no paradox Bentley, the Liger, and delta function, for example. Also, dimension analysis would like to determine dark matter. For example, on the Earth, if we have dark matter in dark room, which temperature 300 Kelvin and characteristic speed of sound, which value 330 meter per second, we can calculate exactly using dimension analysis mass number of air. Now, for example, we have at present time for this parabola value atomic mass units 29 for in our dark room on the Earth. But if we have cosmic space and dark room in cosmic space, in this measurement temperature 2.7 Kelvin and have speed of light and Boltzmann constant. And if we use just the same dimensional analysis, we have mass of matter by in cosmic particle 5.7 kilogram. And also, if we use average density of our universe, we can calculate characteristic gravitational frequency and period using dimensional analysis. Where dimensional analysis exactly show us mass of physical vacuum. Now, for example, temperature such of value temperature 2.70 Kelvin Reginer just registered 1933, and after Shmaonov in Pulkovo, St. Petersburg, Penzias and Wilson 1963, and Smith show that exactly our cosmic space has temperature 2.7, and we use this 0.7 and use dimensional analysis. We have exactly mass of particle in our cosmic space. Also, our paper uses string theory, but not on Euler function. For example, we use more simple string theory and show just later more simple value of our space. Now, for example, electromagnetic plane wave show here as string theory. Also, if we use such type of equation for potential force field, we can use exactly green function as a solution of this value and to consider different problem for green function, for example. The main 10 commandments for my presentation. I use Epicure absolute time, Euclid absolute three-dimensional space, Galileo's invariance, Newton mechanics, area continuum medium, Maxwell's electrodynamics, Debye-Sheldon, with the main Debye-Sheldon of points, Boltzmann kinetic, and the Hopital rules. If 0 on 0, we can go from this point, saddle points. And I show here experiments, exactly experiments of this century, which show us many super light velocity for matter. And Epicure absolute time just exactly as Newton in the beginning. You also second Euclid's absolute space, also just Galileo invariance if we just use transformation between coordinate and with motion with velocity where Newtonian mechanics we use and Euclidean continuum medium. If we use density of medium, impulse of matter and energy of matter points, we can calculate using such type of Poisson equation and have, for example, for our Earth, exactly solution and force field. Now, for example, here present detailed calculation of such type of equation. Also, conservation law allows us consider not only stationary, also for unsteady problem. Here present equation conservation law, mass conservation law, impulse and energy. If we use state equation, we can calculate distribution of force field for different system. Also, I show you here integral conservation law, mass, momentum, and energy more for, as a finishing equation. Where six my points. We use Maxwell electrodynamics and displacement current, which allows us displacement current to show shielding of charge. Also, polarized electron in vacuum space. We just use Debye shielding for electron and proton. And for example, here show Debye shielding of the electron, for example. Maxwell electrodynamics model show here on the left, but we use such type of gas dynamic approximation for dark matter string model. Here show element of string theory. Another we have Debye shielding. I would like to show more detail Debye shielding, and in this case we have such type of behavior potential. Now, for example, for two-dimensional case, and if we have a Coulomb law for charge, we have Debye shielding such type of value, and for Newton law, we have also this shielding allows us to consider just exactly the same gravity and electrodynamics problems. Here present Boltzmann kinetics and how we can calculate with problems, and after rules, L'Hopital rules allows us to go from saddle points, and we have black hole. Also, for example, we have exact solution for black hole and cosmic jets from these black holes, which exact solution was published in paper Accurate Dark Matter Theory, and exact solution 20 years ago. And exact solution for black hole and jets following from this equation. For example, here we present once more experimental data and superluminal cosmic jets from different galactics. Also, if we would like to consider nuclear problems for exactly first electron image, which was published this year, we can calculate potential distribution in this electron image, and we can see that gravitation and electromagnetic problem we can solve using for study case using one equation system. United theory, in this case we have for electromagnetic, electroweak, strong, and gravitation force field. For example, for electromagnetic we use spread of Maxwell equation system. For electroweak, for proton, neutron, we have also distribution of force field. And United theory electromagnetic, strong, and gravitation, if we use our equation, Poisson equation, we can consider density, pressure, concentration, and debye screen radius for electromagnetic in space, for electroweak, Bose condensate, electrostrong permicondensate, and electrogravitation for Earth. And only with case we have different pressure, different concentration of dark matter, different density, and we have different debye screen radius. For example, for Earth gravitation screen radius 86 kilometers. And once more, I would like to emphasize modeling electromagnetic and gravitational force fields for the same position. We can calculate using gravitation constant and electromagnetic constant exactly relation between mass and charge for our Earth. For mass our Earth with one, using such type of coefficient, we have exactly charge of our Earth, common charge with 5 on 10, 13 coulombs. In this case, when Earth is swirling, give us with magnetic fields with angstrom per meter with values. Therefore, we consider string gravitation based on fundamental difference structure of polarized space, proton and electron will form a neutron. Also, elementary particle of physical vacuum is classical dipole with known particle properties. The transmission of all type interaction is determined combination of force field, defined gradient electrical potential, and natural pressure of medium. Also, for example, for this equation, I can show you one-dimensional case. For example, here present one-dimensional case in Paris as equilibrium on the string, for example. Also, different two-case demonstration solution of this equation for Earth curve, equipotential surface near the Earth as solution with equation for two-dimensional, for two bodies. If, for example, for trampoline show us as working with the equation for two-dimensional case. Children are moving to the center. Scientists also moving in the centers on trampoline, for example. Where we show a few string theory for condensed matter, for electronic screen surface, for proton screen surface, and for more complex space in this example. Also here present publication such type of work for space energy and another. No, for example, I show you only three books. Gas dynamic elements of dispersive medium. Here present exact solution for this case. Conservation law in modern physics and technical application with also published British book published international. Now also last published physics of entropy, radiation and gravity matter with example of a general and analytical solution. Also book published international of this year. And my conclusion next. The fundamental law of Newton and Coulomb are consequence of a single law which for potential of force field phi is represented by equation Poisson quasi-linear Poisson equation. String theory in this case may be used for simulation of space space of in green function demonstrate as deep unity different branch for the steady physics problem and Newtonian gravitational field theory. My conclusion, classic gravity is the residual Coulomb's interaction of baryonic matter concentration in nodes outside the screen radio by Duquel. In this case, we have the same description of gravity and electrodynamic interaction. Thank you very much for your attention. Thanks.
Thank you, Dr. Michael. Is anyone having any questions?
Thank you very much once more for your attention. Thank you very much.
Yeah, I think there are no questions. Once again, I'll thank you, Doctor, for your presence and presentation. Let's have a lunch break for half an hour. Stay connected. Thank you for your patience. Let's start our afternoon session. Our next talk will be Dr. Boris from Kipjet Institute, Russia. But due to some emergency, he was unable to attend today's webinar, but he has provided his presentation. So I'll be displaying his presentation now. Thank you for the presentation by Dr. Barcio. If anyone having any questions, you can mail to the concerned program manager. They will be responding back. Our next presentation will be by Dr. Sengovo Wo, Ethiopian Technical University, Ethiopia. Doctor, are you ready with your presentation?
Hello.
Yes, doctor.
Yeah, I'm ready to present.
Okay, now I'm going to make you as a presenter now. Please share your screen.
Yeah.
Yes.
Yeah, I have a meeting. But just wait a minute. Can you see my screen?
Yes, we can see your screen. Please make it as a full screen.
Yeah, I see. But
You need to click on that slideshow button in the bottom of the present PPT.
yeah, I know, but just wait a minute. Yes. Did you see my full screen? Hello?
Yes, we can see your full screen now.
Yeah, I will present.
Okay.
Can I start?
Yes, you can start your presentation now.
Yeah. Thank you for your listen to my presentation. My name is Dr. Wu. Today I briefly introduce the U-derived methodology. And I will present entitled as Improving Reliability Design of the Mechanical System, such as the refrigerator. This reliability methodology improves the design of the mechanical system. I will provide two cases of study. This is the automobile. Automobile consists of the engine, transmission, and drive, and the electric and the body system. Total components are 20,000 pieces. Life target is between 10 years. To improve the performance and reducing cost, product will be designed yearly. By live testing, and the engineer should refine the design flows and the product module. This is another mechanical product, airplane. The airplane is consists of the motion system, door, aviation control, hydro control, etc. Total component 200,000 pieces. Life target is between 10 years. This is a refrigerator. Refrigerator consists of the cabinet, door, internal fit, general part, and the control part. Total components are 2,000 pieces. Life target is between 10 years. This is a definition of the reliability. Reliability can define as ability item to require the function under the state environmental operational condition for the specified period of time. Most of the mechanical product is that reliability can describe the bathtub. And if I follow the bathtubs, the product will be rejected because of the initial failure rate, higher failure rate, and a short lifetime. And because of that, the companies set up the reliable closed plan. And finally, and the bathtub will change to the straight line. Product reliability can be achieved without design failure. This is a thinking picture of the RMS Titanic in 1912. It came from the cold seawater, British steel, and the temperature. The stop of the side and the Titanic and the stop and the iceberg and the crazy hole. Finally, and the RMS Titanic had 2,000 people is on board. It takes 2 hours and 40 minutes to thinking and drown to death, and more than the 1,500 people. This is another disaster challenge. It came from the lucky booster shield with two lava. It brittle the O-ring and the winter's weather. As a result, this debacle occurred in 1986, in which all crew members lost their lives. Sadly, and all the Americans are suffering and self-esteem because of the failure. This is a Calypso present of the bridge in 1967. It came from the metal fatigue and the critical eye bite due to the random traffic load. As a result, in December 15 and 1967, Silver Bridge collapsed under the weight of the rush hour traffic, resulting in the death of the 46 people. This is a crash of the de Havilland Comet. This is the first commercial jet airline. It came from the structure failure resulting from the metal fatigue in the airplane. As a result, and suffering and the catastrophe in flight after years entering in the air service, with the 3 comets lost with the 12 months in the highly popularized extent. This is the failure and the mechanics and the product design. This is a structure, and the structure is a subject is repetitive stress. There are some the design flaw, and the products will be collapsed in each lifetime. The issue, how to find the design flaw and the level and the probability. The solution is live testing under the accelerated testing. This is a solid state and diffusion impurity in silicon. It takes place micros of the migration induced voiding built up by the chlorine and the iron, trapping and the electric and the holes. This is a junction function. If I take electric field of fluoride, the junction function will be distorted. Finally, the junction function will be described sign hyperbolic and the exponential. This is a junction function, and if I take inverse, we can find the general stress model. And the issue, how to describe and the sign hyperbolics. Sign hyperbolic is starting in the linear, n-power stress, and the exponential. Most of the stresses can take place in the medium stress range. And finally, time to failure is describe the n-power stress and the exponential. This is the power of the multi system. Power can be defined as the product effort and the flow. For example, the mechanical translation effort is a force, flow is a velocity. Most of stress came from the effort, and we can describe the acceleration factor is the ratio of the effort and the temperature difference. I will explain how to derive the sample size equation. And but if I follow the Weibull distribution, the life function is defined as a function of the shape parameter and the characteristic lives. If I take the inverse, we can find the Vx lives. The issue, how to the finding the characteristic lives. Characteristic life are defined as from the testing data. Finally, and the Vx life is the function of the chi-square and the logarithmic function and the testing data. This is the Vx lives, and there are two approximation. One is a chi-square approximation, and another one is a logarithmic approximation. Computed level is 60%, R is less than 4, and the chi-square function is approaching R plus 1. And the accumulated failure is less than 20%. Logarithmic function is approaching X. If I rearranging, can the finding and the sample size equation as the following. I'll give you one of the case of study, and this is a refrigerator. This is a redesigned the compressor with a crankshaft. And there are a lot of design faults in the compressor. We don't know which part was. Compressor lifetime depends on the parametric part. To find it, and it requires the reliable function. This is a parameter design schematic. Compressor is designed to the increasing pressure from the low and the higher. We don't know how to use the customer use condition, and the engineer design each part optimally, and we can achieve the optimal design. Finally, and the derived methodology consists of 3 parts, and the failure is from return product, and the parameter are the design the modification. Finally, and the checking and the product achieve the lifetime target. This is a damaged product in field. This is the compressor. This is crankshaft. We found a lot of the wears due to the lubrication problem in field. It came from the improper design of structure to modify and reproducing by parameter art and collector. This is a load analysis for the Excel testing. This is a vapor compression at the cycle. It consists of a compressor, condenser, and the coupler tube and the evaporator. This is a test diagram. From the conservation of the mass in coupler tube, energy balance in the condenser and the evaporator, we can determine and the evaporator and the condenser. Finally, and we can define the time to failure is the pressure difference and the temperature. I will explain how to calculate and the accelerator factor. Accelerator factor is dependent of the ratio of the pressure difference and the temperature difference. For pressure, the worst of case pressure difference is 1.07. For accelerator testing, we increase the pressure from the 1.96. We supposing and the lambda is 2. We can calculate accelerator factor is 3.4. For temperature, and but the worst case and the dome temperature is 90 Celsius. For accelerator light testing, we increase the temperature 102, and the accelerator factor is 1.4. Total accelerator factor 4.6. We apply a duty design and we search for the design failure. This is a calculation mission cycle. The life target of the domestic compressor is beyond 10 years. Accelerator factor is 4.6. Total sample size of domestic compressor is 100. The compressor lifetime is at for 10 years, almost 87 at the 1,000 cycle. There is no problem in the 19,000 cycle. We can guarantee compressor lifetime is beyond 10 years. This is equipment used at the accelerator testing. This is the test jigger. This is the schematic diagram, and we can proceed the parameter art with the equipment. This is the result of the first parameter art, and the compressor lot due to the lubrication and the 7 and the 10,000 cycle. This is the field photo. This is the result of the first parameter art. Both photo is very similar. By parameter art, we can reproduce a compressor failure in field. And we check in the design and the compressor. We find these three and the design problem. One is a low lubrication area. Another one is the low starting RPM. And then the crankshaft material. As an actual plan, we design and the crankshaft. We changing and the dimension, adding in the U glue, and modify and the material. By parameter art, we can collect and the compressor design failure. This is another result of the second parameter art, and the crankshaft wears found in the 19,000 cycle. It came from the interference between the crankshaft and the slash word due to narrow clearance. This is the old design, and this is new design. We modify a clearance from the 0.1 and 0.5. By parameter, we can modify design port and the compressor. This is a summary of the parameter art result. There is no problem in the compressor in 90,000 cycle. In first parameter, we found in the lubrication problem. And then we modify and the design and the changing material, adding U glue, and the modify and the RPM. In the second art, we also finding in the wear problem. And as an action plan, we increase the clearance between the washer and the crankshaft. In third art, there is no problem 19,000 cycle and the 20,000 cycle. Compressor achieved the life target beyond 10 years. This is another case of study, hinge kit system. This is a refrigerator. This is a hinge kit system. Hinge kit system consists of several parts, and the cover, wall dam, spring, and the housing. There are a lot of the design part in hinge kit system. We don't know which part are. hinge kit system lifetime is dependent on the design port of the part. To find them, it requires a new reliable methodology. This is a parameter design schematic. Hinge kit system is designed the closed door and the smoothly. We don't know how to use and custom use condition, and engineer should have designed each part optimally. Reliable methodology consists of three parts: failure analysis and return product, failing with art and design modification, finally checking and the life target achieved. This is a damaged product in field. This is a hinge kit housing. There are a lot of the crack on the hinge kit housing. It came from the fragile structure. By the refurbishing and failing with art, we can collect them. This is a load analysis for the XLI testing. The hinge kit system depends on the door weight. To increase the impact, we adding and two additional weight on the end of the door. By controlling and the impact, we can carry out the XLI testing. I will explain how to calculate XLI effect. XLI effect is dependent on the ratio of the impact. For worst of a case, the impact is 1.1. For XLI testing, we increased the impact to 2.8. We supposing and the lambda is 2. XLI effect is 6.3. We are applying and the duty cycle. We can search out the design failure. I will explain how to calculate the mission cycle. Life target of hinge kit system beyond like 10 years. XLI factor is 6.3. Total sample size of hinge kit system is almost 6. Hinge kit life target is for 10 years, 36,000 cycle. There's no problem in the 41,000 cycle. We can guarantee and the life target is a hinge kit system beyond like 10 years. This is equipment used at the XLI testing. This is a test jig. This is a controller. And we can proceed and the parameter art with the equipment. This is the result of the first parameter art. At the hinge kit housing, hinge kit system collect and the 3 and the 50,000 cycle. This is a field photo. This is the result of the first parameter art. Both photo is very similar. By parameter art, we come the reproducing design flow and the hinge kit system. To reinforce the fragile structure and hinge kit housing system, we adding some rounding in the outside. We added some rounding in the inside. We also adding to the reinforced leaf and the housing and the deck. This is another result of the first parameter art. We found the lift oil damp. It came from the parametric shielding structure. This is old design. This is the new design. By parameter art, we can reproduce and design port and the old damp. This is another result of second parameter art. Housing covered hinge kit system collect and 7 and 9,000 cycle. It came from the material problem. When you're operating and the hinge kit system and the old damper spot is strike and the hinge cover finally and the fracture. As an action plan, we modify and the material from the plastic to the aluminum die casting. By parameter art, we can modify the fragile housing cover the hinge kit system. This is a summary of the parameter result, and there is no problem in the 41,000 cycle. In post parameter art, we founding and fracture of the hinge kit housing. Also, we founding and leaked oil damp. As an action plan, we modify and design of the hinge kit housing and the oil damper. In second art, there is no we founding and fracture of the housing cover. It came from the material problem. We modify and the material from the plastic and the aluminum die casting. And in third art, there is no problem. The 41,000 cycle and the 74,000 cycle. Conclusion: This is my paper submitted to the Reliable Engineering and System Safety, entitled Reliable Design and Case of Study and the Design Compressor subject to the repetitive internal stress. This paper is described and my reliable methodology. This is another result of my methodology entitled Design of the Mechanical System based on Statistics. This book is enabled to the mechanical civil engineer to find the design flaw and achieve the target product reliability. It also suggests a variety of case of study on the mechanical system, present the Daguchi method, alternative experimental methodology, describe and use the parameter art method, reliable quantitative testing and specification. Thank you for your listen to my presentation. Do you have any question?
Thank you, Dr. Rio. Is anyone having any questions? I think there are no questions. Thank you once again for your presence and presentation, Dr. Singwo. Let's move to our next presentation by Dr. Yep, thank you. Let's move to our next presentation by Dr. Vadim, but due to some emergency, he was unable to attend today's webinar. And our next presenter by Dr. Massimo also unable to attend today's webinar. So let's move to our next presentation by Dr. Tatayuki from Tohoku University, Japan. We're having his recorded video presentation we'll be displaying from our side. If you have any queries, you'll be sending an email to our respective program manager. They'll be sending your answers for these queries. Can everyone hear the volume? Nitish, వినిపిస్తుందా? I think few speakers are unable to hear the video presentation. We'll be sharing another presentation in the another screen. Please allow me 2 minutes so that I can share the presentation. Okay, now I make presenter as Simon. Simon, please share your screen for the presentation. Apologies accepted. Please, due to some technical issue, we are unable to play the video. Give us a few moments, we'll play again. Sorry for the inconvenience caused. We'll be displaying another recorded video presentation by Dr. Shubhashi Sins.
Yeah, hello everyone. Is the audio is audible to everyone? Not everyone. Can you please let me know, is it audible to everyone or not?
No.
Okay, I think the video has some problem. Uh, just a minute. Please allow me a few moments. I will share my screen with another system. I think the video has some problem with the audio. Thank you for waiting. Please allow me a few moments. Thank you for your patience.
Okay, thank you.
This conference will now be recorded.
Thank you very much for coming today. The title of today's presentation is Establishment of New Synthetic Fluids for Next Generation Magnetic Material using Microwave. First of all, I will talk about permanent magnetic materials. It has a widely applications such as motors of EV and home appliances. There are two main types of magnetic materials, neodymium iron boron and ferrites. Neodymium iron boron is the strongest magnet in the world. However, this material has a problem on supply stability as containing rare earth elements. On the other hand, ferrites are rare earth-free magnets, but this magnetic performance is low. This magnetic material which has moderate magnetic performance, so-called gap magnet, is needed. The stable alpha-double prime iron nitride is one of the candidates for gap magnets. Therefore, alpha-double prime base is required. The physical properties of alpha-double prime iron nitride have big issues because the true magnetization of alpha-double prime base is controversial, as shown in this table. Theoretical values of magnetization and experimental values of magnetization of thin film and non-critical are inconsistent. Additionally, experimental value of sound out is not revealed because single phase has not been obtained. Next, I will explain the processing for alpha-double prime iron nitride. In terms of non-critical, iron oxide or graphite non-criticals are used as sorting materials. These are reduced as a hydrogen gas in the alpha iron crystal, and subsequently nitrated as a ammonia gas in the alpha double prime crystals. In this process, crystal diameter of alpha iron has an important role for producing alpha double bond phase, and crystal diameter lower than 15 nanometers is needed. On the other hand, in terms of bulk processing, it is known that alpha double prime phase is also obtained by the same method of particles if the crystal diameter of alpha iron is under 15 nanometers. There are two key issues for bulk processing. One is controllability of crystal diameter, and the other is high oxygen contents. For these reasons, single phase of bulk alpha double prime phase has not been obtained and true magnetic properties is unknown. In this presentation, we will treat the issue of crystal diameter. To control the crystal diameter, we focus on deep crystallization. Deep crystallization has been reported for ferrites irradiated with 2.45 GHz microwave, which has non-domain structures. This phenomenon is considered as non-thermal effects, and its mechanism has not been revealed. The purpose of this study is actively controlling the crystal diameter of magnetite by using microwave to establish the new synthetic groups for alpha double prime iron nitride. New synthetic groups proposed in this study is as shown in this graph. Next, I will go on to the experimental method. We use the 2.45 GHz microwave furnace. For the raw materials, we selected magnetic powders that exhibit deep crystallization phenomena. 0.3 grams of magnetic powder was weighted and set as shown in this video. The microwave cavity was evacuated using rotary pump and subsequently replaced with nitrogen gas. Each sample was irradiated with 2.45 GHz microwave at 2 to 1100 degrees for 0.2 to 60 minutes. The samples irradiated with microwaves were characterized by X-ray diffraction. In this slide, X-ray diffraction of magnetic powder irradiated with microwave at a different temperature for different time duration is shown. In terms of magnetic powder irradiated with microwave over 300 degrees, oxidation is proceeding and hematite phase was appeared. From the X-ray patterns, crystal diameter of magnetite was calculated by using Scherer's equations. Temperature dependence and time dependence of the crystal diameter is shown here. As for temperature dependence, the crystal diameter of magnetite took the minimum value of 33.1 nanometers and 500 degrees. On the other hand, as for time dependence, the crystal diameter of magnetite took the minimum value of 33.1 nanometers for 5-minute duration. Next, the temperature dependence and time dependence of the crystal diameter of magnetite will be discussed. At first, I will discuss the temperature dependence. The simulation of the interaction between spin of magnetite and magnetic field of microwave is shown here. As a result, imaginary part of the susceptibility minimum value 500 degrees. From the result, it is guessed that when the energy loss of the interaction between the spin of the magnetite and magnetic field of microwave is largest crystalline diameter takes minimum value. Secondly, I will discuss the time dependence. The power profile of microwave during processing is shown here. For the first 5 minutes, the microwave power was unstable. On the other hand, after the 5-minute duration, the microwave power showed almost constant value. This might mean that microwave energy absorbed by magnetite part will change into interfacial energy for first 5 minutes. To summarize, the crystalline diameter of magnetite was successfully controlled by microwave irradiation. Next, I will go on to the synthesis of alpha double prime iron nitrides. Synthesis was conducted as shown in this flow. The exotic patterns of the obtained sample, each of the steps are shown in this slide. As a result, no advantage was observed by using microwave irradiation. To consider why, crystal diameter of the product in each of the steps was calculated from the Scherer's equation as shown in this table. According to the table, crystal diameter was grown during hydrogen reduction at 400 degrees, resulting in no difference, which is considered as a new problem. To lower the reaction temperature, I focus on lowering temperature of water vapor. H2 over H2O ratio, reduction potential is enhanced and reduction temperature can be lowered. Additionally, oxygen content in the material can be controlled. I assume the use of drying agents during reduction such as calcium hydride and calcium oxide. Next, I'll show the preliminary results. Reduction of magnetite is conducted by using calcium hydride as drying agent under hydrogen gas. As a result, H2 over H2 ratio was controlled by using drag agent, and reduction temperature was successfully lowered. Future work is needed such as nitridation to alpha double prime iron nitride and measurements of magnetic properties. Finally, I'll summarize this presentation. We have a big issue: determination of true magnetization of alpha double prime phase. To realize it, improvement of bulk processing for alpha double prime phase is needed. In the study, the crystalline diameter of magnetite was successfully controlled by using microwave irradiation. At the same time, the problem was advised: lowering the reduction temperature to suppress the growth of the crystalline diameter is needed. As a preliminary note, reduction temperature was successfully lowered by controlling H2 over H2 ratio. Future work is to alpha double prime iron nitride and measure their magnetic properties. The references are shown in this slide, and this is all for my presentation. Thank you for your attention.
Thank you, Dr. Tatuki. We'll be displaying another recorded video presentation by Dr. Shubhashi Sen.
Speaker screen splitting.
Greetings to friends and colleagues. I am Dr. Subhash Sen from Kolkata, India. I am a geologist from the Council of Scientific and Industrial Research of India in 1996. I did my PhD in geology from Nagpur University in 1974, and before that, I did my MSc in geological sciences from the Jadavpur University, Calcutta, in 1916. I've been working on several problems of earth science, particularly on the structure of the earth and the interior of the earth. Here, I would like to discuss about the interior of the earth, in particular reference to magnetic properties of the planet. You know that the earth has been divided, the thickness of the earth has been divided into three principal zones, which we call geospheres. At the top of the crust, the thickness of the crust is 33 kilometers, and below that occurs mantle, made of basic igneous rock, and its thickness is 2,867 kilometers. Below that occurs a fluid zone, thickness of which is 2,207 kilometers, and this is known as outer ring in the prevalent concept. And the prevalent concept considers that this fluid zone is made up of liquid iron, and below that, the innermost part of the earth, that is 1,251 kilometers thick, it is known as inner core, made of solid iron. Well, we don't know how this fluid zone has occurred in between the two solid zones. This is the crust, 33 kilometers of truth, and then mantle, solid, outer core, fluid zone. According to prevalent concept, it is made up of liquid iron, and below that, the innermost part, the core. And this solid, made of solid iron. Well, what we find that I follow the concept of Earth's expansion. I would like to show as regards the continental drift theory. If we try to adjust Apparently, it appears these two are parallel. The full lines are parallel, but if we try to adjust this, we won't be able to do it in a perfect manner. If we can adjust this portion, we would be able to adjust, but there will be a big gap in the southern part and vice versa. This is the very first map of it was prepared by Abraham Otilas around 1570. And even in this map, it is clear that these portions looks like that they were joined together in the past geological time. And several scientists have tried to adjust these continental fragments, but they could do it only by in an approximate manner by distorting the show lines. This is an example of the map done by 1912. This map was prepared by the German meteorologist Alfred Wegener. He did a lot of works on both the shorelines, geological studies, planetological studies, and he showed that these two must have been joined together in the past geological time. But what he did, he had to, for adjustment, he had to distort the shorelines. This is not a perfect scientific work. And there is another concept on Earth which is known as Earth expansion theory, which means that initially the planet Earth was quite small. And if we follow that concept, perfect adjustment of all the continents will be achieved. This is quite an old work, but I am showing you the map done by Hindenburg in 1933. Hindenburg reduced the radius of the Earth by 1/3 of its radial thickness, and he found that in all the small map, all the continental fragments could be adjusted in a perfectly symmetric manner. So I followed this concept because it's giving in which all the continental fragments could be adjusted in a proper manner. But one thing we must note that in this small Earth, the entire Earth, almost entire Earth, would be covered with a silicate cover that we call crust. Although there may be a few lakes or epicontinental seas, but they are only in ocean, which means that the ocean water must have been associated with the mantle in the small Earth. Before expansion, the water, ocean forming water must have been associated with the mantle. According to a work done by Roy and Darby in 1961, they showed that if a silicate rock contains large quantum of water under pressure, the melting point of that rock would be depressed. Or in other words, the melting point would be lower down and it would become somewhat fluid-like, fluidity would be increased. So I consider that when in the large quantum of matter was associated under pressure, the melting point of the matter must have been lowered down, or in other words, some sort of fluidity was increased in that rock. It was semi-fluid. And under that circumstances, if this is a eventually semi-fluid, and if any outside gravitational force is attracting the planet Earth, imagine will be burst and hence not will expand. Well, it is very clear from this discussion that originally the moon was not present over the surface of the earth, near the surface, near the earth. Moon wasn't there. So moon has come later, and I consider that moon came near the earth, and it was captured by the larger planet Earth. And since then, it started moving around the Earth in this way, moving around the Earth, and from that, the expansion of the planet took place, essentially affecting the semi-fluid band. And because of that, lot of cracks, expansion cracks over developed over the surface of the earth, through which lot of volatile matters came, and the main product that came out was lava, molten lava, and the molten lava spread on both sides of the tracks, and at the same time, as the planet was increasing in size, the fragmented continents were moving apart, and in between that zone, rudimentary ocean was formed, and as the fluid, as the planet was increasing, and along with the mantle, lot of volatiles also came, and that volatile was chiefly constituted of water. And that water on condensation formed ocean water. And the planet was expanding. All these events took place in a concurrent manner. And as the planet was expanding, the water also came out, and ultimately a stage was reached finally when the entire part of volatiles, chiefly constituted of water, came out. At that stage, the expansion of the planet was stopped together with enlargement of ocean. So in this way, everything happened. And another very important thing is this, which has not been noted by the contemporary scientists, is this, that the thickness of this outer plate, thickness of the outer plate, which is considered to be fluid, and the extent of expansion matches. These two figures are the same. So, from that, I would like to interpret that this zone, outer plate, has been opened up as a void zone because of expansion of the planet. That alone, some portions of material came out from mantle, and because of that, this part is given a pseudo-fluid characteristics. It is not a fluid zone. It is a void zone, but it is giving somewhat fluid characteristics. And I consider that before development of this zone, the mantle and the inner plate were juxtaposed to each other. And gradually this was opened as a void zone. Now the structure of the arc is like this. This is the solid inner plate and the mantle is solid. They are separated by a virtually void zone. Under these circumstances, apart from the inwardly directed force of gravitation, the force of gravitation in the reverse direction would also occur because the mantle will pull the core, inner tail. And because of that, reverse gravity will be developed in this zone. Hence, the iron core, which has been considered in the prevalent concept that there is not a magnet because the temperature here is very high, on the order of 3,500 to 4,000 degrees centigrade. As we are going down, then according to the prevalent concept, temperature and pressure increases. And here it is so high, magnet cannot solid state because of high temperature. Inner core cannot be a magnet. Though it is made of iron, it is solid, and at the same time magnetic lines of force emanate from this zone. Prevalent concept considers that this is not a magnetic zone. Well, I have shown that the temperature and pressure would be must be below the cool point of iron, and because of that, the coal is a magnet. You can expect the iron core, which is made of iron, through which magnetic lines of force must be met. Well, this is the basic thing I wanted to convey, and at the same time, I would like to show that it has been found in comparatively different geological data. The sedimentary rocks, the data have shown that if there are some iron particles, if we study the iron particles, we should show that the magnetic, several new magnetic phenomena like polar wandering and pole reversal has occurred in the latter part of the geological history. This, how it has been happening, I would like to say that initially the inner core and the mantle were juxtaposed to each other, and the outer core or the fluid zone, which I call a virtually void zone, was not opened up at that time because if a magnetic planet comes near the Earth, it would be magnetically affected and gradually it would rotate. And there are precise records that the planet Earth has rotated because this magnet, when the magnet is rotating, the mantle and the Earth will also be rotating. And gradually, because of the gravitational attraction of that planet, this was fragmented. This zone was fragmented and gradually a void zone developed within this. And at that time, the smaller planetary body was captured by the Earth and it started to rotate around the Earth in this way. As it was rotating, the expansion occurred. And at the same time, this zone was increased in size, and gradually, when the entire water from inside the mantle came out, the further expansion of the planet or the formation of ocean, enlargement of ocean was stopped. This is that stage. At that stage, the outer core of the void zone was sufficiently developed, and within this, the inner plate, which is a magnet, rotated inside. And that's why, as it was rotating, the phenomenon of lunar wandering took place, and pole reversal also occurred because this north pole came towards the south magnetic pole and vice versa. And in this way, all these things happened. And I think this is another simple concept, and the concept which is known as dynamic theory. We do not require to perceive the dynamic theory that there is this sort of dynamic in the interior of the Earth, and because of that, the magnetic properties of the planet has been developed. I want to say in a straightforward manner that the Earth's inner core is itself a magnet, and because of that, this magnetic phenomena are occurring in the planet Earth. Thank you very much.
By this, we came to an or Day 2 webinar. I would like to thank all the attendees and participants of today's webinar. Hope you all enjoyed the webinar and gained the knowledge from the sessions. And we'll be glad if you could join us on next webinar, which is scheduled, and the dates will be announced to you by email. We will be very happy if you could share your opinion and feedback with us. Thank you once again for your presence and presentations.